Hello guys, welcome to our today's topic of interest. We are looking at continuity. And this is under complex analysis. Continuity under complex analysis. We want to understand how to tell whether a complex function is continuous or discontinuous. So we'll have to begin by a definition, and we will say that a complex function denoted by f, a complex function denoted by f is continuous at a point z naught if each of the following conditions if each of the following conditions are met. So we have three conditions for a function to qualify to be continuous. So the first condition is if the limit of a function as z approaches z naught exists, then we will have to say that function is continuous. The second one, if the function is defined at a point which is z naught, then that function is continuous. Rule number three, if the limit of the function as z approaches z naught is equivalent to f of z naught, then we will say that the complex function or that function is continuous. Let us have a question to enable us understand this concept fully. Let us have a question down. And remember, if the three conditions that I have mentioned are not met, we will say that function is discontinuous. So we have a question that reads, show that the function f, this is the function z squared minus I z plus 2 is continuous at a point z naught which is equivalent to 1 minus I. Remember, when we talk about complex numbers, they have real parts and imaginary parts. I hope you remember that. So let us give a solution. And we want to ascertain that the function that is given at this point, it is continuous. So our function, this is the function we have, is equals to z squared minus I z plus 2. For us to solve this, we'll have to introduce limits and say the limit of a function which is given here plus 2, this is the function, as z approaches the point is 1 minus I, that is the point. So what we are going to do, whenever we see z, we replace with 1 minus I. So let us continue and say that the limit of, now the limit of, we open the bracket, 1 minus I, then we square this, minus I, then z is 1 minus I, we close the bracket, plus 2. Now we will continue by expanding. We continue by expanding. We will use our high school concept that says when we have a minus b squared, this is the same as a squared minus 2ab plus what? Plus b squared. We also have to remember that I squared is the same as negative 1. When you have I squared, this is the same as negative 1. So let us expand very fast. So we have 1 minus 2i, then plus I squared. This is negative I, then plus I squared plus what? Plus 2. Let us put the like terms together. We have 1 minus 2i minus I plus I squared plus I squared plus 2. Remember I said I squared is the same as negative 1, negative 1. So we will have 1 minus 3i, then now this one will change to a negative, minus 1 minus 1 plus 2. This is the same as minus 2 plus 2, which is the same as 0. So the final answer is 1 minus 3i. Therefore, we say this function is continuous. Thank you so much. Continue watching, subscribe, and share this video widely. Thank you so much.